the last addressing mode we are going to look at is relative addressing. So when I was explaining the need for addressing modes, there was this one point I mentioned, which is your computer memory is vast. The memory locations themselves take up a lot of bits. So if you use certain addressing modes, instead of a 20-bit memory location, you can bring it down to 10 bits or 15 bits. So this relative addressing mode is exactly what helps you do that. So let us assume you have memory locations which are 20 bits long each. So let's say it is 10000, some 10 zeros followed by 0, 1, 10 and so on. So basically your memory addresses are 20 bits long and they are sequential. They are incremented by 1 each. So it is only the last 3 or 4 digits, worst case, which are going to change. The first 16 digits are the same for all the bits you will be accessing. So if you let's say you are accessing 5 of these bits, so the address of each bit, like I said, is 20 digits long. So in your instructions, if you are writing 5 instructions to access 5 bits, and each instruction, the memory part alone will take 20 bits. So just for the just to store the memory addresses of these 5 pieces of data, you will need 20 into 5 is 100 bits. Apart from that, you have the opcode and other stuff. So your instructions are going to be very long, right? So instead, if you know that the first 15 bits are going to be the same for all the pieces of data I am accessing, and it's only the last 5 bits that are going to change, then what you can do is you take the first 15 bits, you put it in one register, let's say the accumulator. Then when you are writing the instruction, you give the opcode and the last 5 bits alone. So what your system will do is, it will take those 5 bits, it will add it to the accumulator. Remember, the accumulator just adds the data. So it will you have those 15 bits followed by 00000, and then you take that last 5 bits, you add it there, you will get your 20-bit address. Then you go to that 20-bit address, you pick up the data and do whatever you want. So the advantage of this technique is, now how much space do you need to store your instructions is 5 bits for one data. You have 5 pieces of data, so 5 5s are 25, plus that one time storage of 15 bits. 25 plus 15 is 40. So you needed 100 bits to store certain memory locations. Now within 40 bits, you are able to store the same amount of memory. So that's a 60% reduction in size, even for accessing 5 bits, right? So if you're going to access thousands and millions of bits, you can see how much of a reduction in the space required there will be. So that's the idea of relative addressing modes. So in short, what this mode does is, it takes one part of the memory address, a string of digits, puts it in the accumulator. The part which we know for sure is going to remain the same across all the data we are accessing. Then the remaining part, which varies from one number to another, that alone keeps changing for every instruction. And when you have an instruction, it will take this variable part, add it to the fixed part, and it will go to that memory location and it will access the data. So this is like, to give you an analogy, if you have seen the speedometers on two-wheelers, not the speedometer actually, the thing which tells you how many kilometers this vehicle has run. If you see, there are digits, there are 5 digits or 6 digits, and only the last digit keeps changing. The remaining digits, they're all the same. As the mileage, as the number of kilometers increases, only the last digit keeps changing. And then when it hits a 10, the second last digit alone changes. When it hits 100, the third last digit alone changes. But most of the time, it's only the ones place digit which keeps rotating, and the others remain the same. That's exactly the logic here. Your one part of your address is fixed. It is put inside a register and it stays there. The part which is constantly going to change from one piece of data to the next is alone written in the instruction, so that the amount of space required to store instructions, to store memory addresses in instructions, is reduced. So that's the idea of relative addressing.